Introducing AmphiBOT, a project by our group ONS. Currently, research shows that 9 Malaysian cities could be submerged in the next 30 years, and it will cost up to $180 for each citizen in KL due to flooding in 2050. These predictions show the increasing risk of flood in Malaysia, but how efficient is our flood rescue relief response system actually is? A research done on Pahang's flood shows a few main challenges such as shortage in manpower, logistical assets, communication, and lack of coordination. Thus, after identifying the main problem, we understand that we need to achieve these hypotheses and objectives. We want to achieve multifunctionality, autonomous, detection available, data fusion, and real-time communication through a digital technology solution to support flood relief. This can be done through features of supply delivery, survival detection, live reporting, and safeguard of victim important belongings. From these objectives, we brainstormed a robot design named AmphiBOT, an amphibious rescue support robot that can move in land and water to move autonomously or remote controlled in order to search for victims, deliver crucial supply, communicate with survivors, and safeguard their important belongings.
The main innovation of this AmphiBOT is about its amphibious tire, which allows the robot to move flexibly in both water and on land. It acts as a propeller in water and a tire on land. The boat-shaped model allows the storage and sending of basic need supplies to victims of natural disaster, while also helps to store valuable items of victims. 4 float bags are also included on the walls of the AmphiBOT that increases the buoyancy of the robot. This allows more supplies to be carried at once.
This is a 360-degree showcase of our AmphiBOT design, including all the components.
The table on the left shows the electrical components and their approximate prices that is needed for our autonomous robot. The functions of the electrical components will be discussed on the next slide. The total estimated cost for our robot will be 343 ringgit 55 cents. For additional features for emergency purpose, RC modules, which is remote control modules, is suggested to be used. To add on RC, the extra cost will be 56 ringgit and 20 cents. The cost minimizations while maintaining required functions is our objective to ensure that AmphiBOT can be obtained at a reasonable price by various agencies across Malaysia for widespread usage. Here are the electrical components and their functions of our robot. First, we use ESP32 cam, which is a camera module to allow real-time connections and live footage for rescue team to search for victims. Next, we use compass module for heading detections to ensure AmphiBOT move in the right direction. Besides, we use GPS modules to pin locations and track locations of our AmphiBOT and also allow set point for delivery. Next, we use PIR sensor, which is a thermal sensor for human or animal detections using thermal radiations to find our victim. Besides, we use microphone to detect sound from the victim and transfer the message to allow communication. Besides, we also use octopus speaker modules to transfer message from rescue team to victim. Furthermore, we use ultrasonic sensor to allow obstacle detections for AmphiBOT to prevent hitting destructive objects for autonomous usage. Next, we also use LED strip to allow visibility in the darkness as flood can happen at any time.
Next, I will be presenting our AmphiBOT implementation plan. When a flood occurs and is noticed by agencies, the rescue team will be sent and deploy AmphiBOT to scan the flooded area and identify victims remotely. Once victims are detected, the team pins their location and communicates with them to access their needs. The support teams also begin packaging requested supplies. After that, AmphiBOT will deliver these packages directly to the victims based on the pin locations. Finally, for efficient space management, AmphiBOT retrieves packages containing victim belongings, allowing more room on rescue boats for evacuation. To support our delivery and retrieval system, we propose a collaboration with FloodStack, a flexible storage bag floatable above water surfaces for an extended period of time, allowing belongings to remain buoyant above water in a flood. FloodStack consists of a dual-chamber design, a storage compartment, and a gas inflating chamber that allows the bag to float securely above water for a long period. When activated, the airtight gas compartment expands while the storage area stays still and intact. This ensures victim belongings are safe and dry during floods. Additionally, FloodStack bags can be hooked onto AmphiBOTs. So right now I'm going to talk about the impact and value proposition for our AmphiBOT. So firstly, for the impact, our AmphiBOT enables life-saving deliveries such as water, food and medicine, so the victims are given immediate support. Next, it empowers locals by allowing them to be trained as operators, which leads to self-sustaining communities. Our AmphiBOT is multifunction as well because it can be adapted for rescue, sensing or signaling missions, and finally, it protects critical items such as important documents or medical equipment. And for the value proposition, our AmphiBOT reduces risk to human rescuers by keeping them out of hazardous conditions. With our AmphiBOT smart autonomous navigation, it avoids obstacles and finds the safest path. And unlike helicopters or large rescue boats, our AmphiBOT is scalable and cost efficient. Its modular design allows hundreds of units to be deployed with minimal infrastructure. And finally, it provides immediate access during disasters, reaching areas that are cut off by damaged roads or blocked airspace. And these are our references as well. And that's all from our team. Thank you for listening.